Hi and welcome everybody to a new video about Air India Flight 171. In this video we'll cover the transducer and the fire in the back section. There were reports after the preliminary report had been out that there was a smoldering fire in the rear section of the plane. During the crash, the rear section broke off of the fuselage and the rear section stayed completely intact. Well, almost, but it wasn't destroyed by kerosene fire. And then soon it was found out that there was a smoldering fire in this back section. Let me note that the rudder had been broken off during the impact, but the rest of the rear section stayed relatively intact. In the back section there was found the body of one person. This was a flight attendant, and she died not because of the impact, but because of this smoldering fire in the rear section. So why is this important? Well, it is known that on the previous flight there was a problem, and the problem was with the sensor for the horizontal stabilizer. And according to the protocol, the sensor was malfunctioning on the previous flight. This was displayed on the ICAR's display in the cockpit as STEP POS XDCR, which stands for Stabilizer Position Transducer. And this error is triggered by the CMC, the Central Maintenance Computer. On a Boeing 787, the horizontal stabilizer is trimmed electronically. On other planes, this can be done hydraulically. However, the 787 has 3 sensors on board. One of the sensors was faulty. Air India sent a maintenance technician and he took care of the problem. Afterwards, according to the reports, there was no problem and the plane was released for normal operations again. Probably he worked according to the FIM, the Fault Isolation Manual, which lists what steps have to be done to take care of a problem on board. And there is also a minimum equipment list, which tells which basic configuration a plane needs so it is safe to fly. And according to this, it is okay to fly with one faulty sensor. It is even okay to fly with 2 faulty sensors, but only under special conditions. Now let's talk about this sensor. The sensor basically sensors the position of the horizontal stabilizer. And he sends this info to Flight Management Computer and Stabilizer Position Units, SPUs. Every transducer has 6 pins from A to F. And if a faulty channel is detected, it gets isolated, and depending on the numbers of the sensors, auto trim function will be deactivated. On the right side here are listed occurrences of this sensor type. Or in other words, what would trigger an error alert if this sensor. Like this would be a deviation of 0.3 degrees between the channels, or a signal loss which lasts longer than 100 milliseconds. And also the loss of power supply will trigger an alarm. The sensor, every pin has a function. Like IA is for resolver excitation and B for resolver excitation return. C and D is sine and E and F cosine output. So what happens if there is an error or fault with this type of sensor? Well, it has no direct influence on engines or engine shutdown, but the sensor or some of the sensors together could trigger a shortcut and lead to a faulty bus. and this could lead to a data loss. And following this, the protection logic of the plane may shut down the engines. Remarkably with this flight is that on the flight before, this special error has occurred. Then on the next flight, at the position where these sensors are located on the plane in the back section of the fuselage, this error had occurred. Well, it has to be said that there shouldn't be fire in the back section of the plane because there are circuit breakers and a special circuit breaker step trim which would trigger and prevent fire. However, there could be a continuing problem with this, like moisture, insulation problems, heat, vibration or something else, which would not trigger the circuit breakers but would lead to a problem. The problem could be a shortcut between sine or cosine and lead to further problems. The vibrations during takeoff could intensify the shortcut and would lead to an overvoltage in the rear electronic power control. If an electrical overspreading occurs, the FIDEC could misinterpret these values. FIDEC stands for Full Authority Digital Engine Control. This means basically the computer has the full control over the engines. The pilots can make some wishes, but what happens, FIDEC decides. And if FIDEC does some misinterpretation of the values, there's not much a pilot could do against it because it has full authorization. And this could lead to a fuel cutoff without pilot command. And after this, because there's no power on board, the red gets deployed. Red for explanation is ram air turbine, which is triggered if there's a power loss on board. In the rear section, where the sensors are located, near the stabilizer check screw assembly, there's a lot of wiring harness close, which could burn, like the wiring to the APU, the auxiliary power unit, stabilizer trim motors, etc. However, in the cockpit, the fuel cutoff switches are mechanical switches, yes, but they have no direct connection anymore. Between the switch and the engine are the engine interface units, and they are not mechanically connected. And FADEC, the full authority digital engine control, could shut down one or two engines, like when there's an overspeed warning or a fire, and then it enters failsafe mode and will give a command to shut down the engines. This would not go unnoticed by the pilots in the cockpit. Well, they wouldn't move the fuel cutoff switches in this case, but on their ICAS display there would be the information fuel cutoff. And this is a status, not the mechanical position of the fuel cutoff switches. And as long as it is correct what is translated from the cockpit audio, one of the pilots asked, "Why did you move the fuel switch?" And the other one answers, "Well, I didn't move it." FADEC shuts down, pilots are further informed, engine shutdown, which is displayed or fuel control cutoff. So they could simply watch on the display and they don't need to check the mechanical position of the fuel cutoff switches. Further, the fuel flow indicator would show zero flow in both engines if they had been turned off. This leads to the conclusion that someone must have moved the cutoff switches, but the someone could be the digital engine control also. And some say that there was only a short time period within the both switches were put from the one position to the other within 1 second. And this would indicate this was done automatically. Here we see a scheme where an electrical fault in the tail section of the plane could affect with the flight control electronics and FADEC, and even the stabilizer position sensor could be part of the problem. If there is then triggered a power interruption signal, This could lead to an engine auto shut off. However, it is clear to say that at this moment this is pure speculation because the final report isn't out and the preliminary report is not very detailed on this. But on the other hand, media internationally said or suggested that one of the pilots would have committed suicide. But at this point of the investigation, this is also speculation because there's no proof at this moment that it was really a pilot who switched off the engines. This video, I just wanted to show that there could be a problem with the onboard electronics also, because in the planes of today, there's no mechanical connections from the flight sticks or other switches in the cockpit to the rudder, elevator, or the engines. Every input is checked by a computer, and if the computer decides the input of the pilots is okay, it will follow the request, but if it decides no, this would not be a good move, then it denies action. This could be a disadvantage of modern planes because pilots today have no direct control, ailerons, rudder, or stabilizers, or even the engine. In between is a computer. This computer has full authority. So far, at this point, there are two fractions. One fraction says that there was a technical problem and it is about to be covered up, and the other fraction says that it was a pilot error or pilot suicide because of the available information right now. Then again, for many pilots, it is said that this phase of the flight would not be the best to do or commit suicide because, of course, during takeoff, if the engines fail, the plane will probably crash. But at this low altitude and relatively low speed, there could be survivors, and even the pilots in the cockpit could survive this. It depends on the situation, but there's a chance that somebody will survive. However, if the plane gets into contact with terrain from a high altitude, like 10,000 feet, and there's a crash dive to the ground at high speed, probably nobody will survive for sure. So if a pilot wants to make sure that he dies, he probably would not act on the beginning of the flight, shortly after, or even during takeoff. Besides, if one of the pilots would want to have committed suicide, another question would be why there was a mayday call, and another question was, okay, let's say he switched off the fuel cutoff switches, but then the other pilot recognizes and puts them back. Why would the first pilot, who in this case would want to suicide himself, not act against this and put back the switches again to the cutoff position? Because in his way of thinking, if he wants to kill himself, he would make sure that the switches are in the off position. But in this case, like it's described here, the pilot who wants to commit suicide puts both switches to the cutoff position, and then the other pilot asks, hey, why did you do this? And he says, no, I didn't do it. And then from somehow he gets inspiration, and from then on he doesn't want to commit suicide anymore, but starts to fly the plane, make a mayday call, etc. So even with the suicide theory, there are many questions still unsolved at this stage of the investigation. I will report further if more is known on this case. Here, I want to say thank you for listening to me. I want to excuse me a bit for my English, because in the last years I haven't spoken it regularly and surely would need some training. But I keep training, and the next video may be better, of a better sound quality and linguistics. Well, again, thanks for listening and hope to see you soon in